is. If you haven't taken CSEC 380 yet, you haven't had the pleasure to do homework 3, don't worry, this will be your future soon enough. But just to simplify, just to get started, what web essentially is you interact with it almost every day, well, not almost every day, every day. It's just access through HTTP and WebSockets. And there's 3 big components to web: HTML, which is the structure, CSS to make it look pretty, and JavaScript, where the dynamic content and where you can actually programmatically code the fun stuff in there. Let's see. And with web, one of the big things is JavaScript. You've probably heard of React, maybe Angular, maybe Vue. Those are probably the 3 big ones out there for, especially actually Node.js as well. And JavaScript was released in 1997. It was actually written in 10 days, so that's why some people really, really hate the language, because some people say it's very disgusting. It's just a high level. It's inside Chrome's V8 engine, so if you're using Chrome, it uses Node.js, and conforms to ECMAScript, which is, I believe, around version 8, where you can just do some fancy things in JavaScript. And this is where the dynamic content actually happens. And this is what some of the things that make JavaScript good is where there are a lot of developers who have gotten accustomed to JavaScript and keep creating new packages, which are known as NPM packages, which NPM is essentially like pip in Python, where you can install the packages. There's NPM, there's Yarn, there's NPX, there's a couple. JavaScript is very popular, so there's a lot of good resources to go out there and you can literally Google up, learn JavaScript, and start getting familiar with it. And there's a very common ecosystem where it's kind of the same across everything, no matter what you're doing. Although there are some problems with JavaScript, as this is where some of the issues with just people not knowing exactly what they're doing and introducing bugs inside their code, where they either don't update their packages, allow for cross-site scripting, client-side attacks, and just allow for outdated stuff to occur. And this is where we actually talk about some of the protocols that make web actually possible, and the big one's HTTP, which is the Hypertext Transfer Protocol. And you've probably seen before, for example, status codes like 404, page not found. That's basically a client error on your end, and 200 means the request is made, 300 means redirection. And whenever you make a request with HTTP, if you ever open up Wireshark or Burp Suite, you'll see headers, which essentially can identify one of the big ones as your user agent, which essentially means what browser you're coming from and what operating system, although you can easily spoof that as well. And there's I guess there's really 2 big things of HTTP: get and post requests. Get, where you're fetching the data, and post, where you're actually sending data to the server. And that's where usually some vulnerabilities can occur. And starting with just more concepts of web to actually get some of the fundamentals of the same origin policy, which is comprised of a tuple, which basically defines how content is located. Content is loaded from one source to another. And as you can see down below in that image, it's basically defining where resources can come from. So if you do get inside your web app to another page, that's fine. However, if you see it's a little hard to read, but down the bottom it says no. It's because what that actually says behind the no is an XML HTTP request, which is it's a JavaScript way to make HTTP requests, which would not be allowed as you're going to an outside resource, which is trying to make a request to Yahoo. And with same origin policy, you can basically define where origins are allowed, and you can also leak information though as well. And this is actually where the fun stuff starts to happen, where we start talking about OWASP, which is the top 10 usually. They come off a list every 3 years, every 4 years. A new list should be coming pretty soon. It's where they go over the top 10 vulnerabilities in web applications. Usually the big one's always SQL injection, just injection in general. That's the one that developers are still having a lot of trouble with. Broken authentication. Some of the big ones there are cross-site scripting, XXC, insufficient logging, and insecure deserialization. Those are some of the big ones. And with cross-site scripting, you've probably seen, maybe you've even tried it before inside an enter box. You try putting in script tags alert1, and if cross-site scripting was there on that page, and they didn't code their website correctly, you would see an alert box pop up. You've probably tried doing that once or twice. There's 3 different types: reflected, stored, and self. And with cross-site scripting, the big thing is you're able to execute arbitrary JavaScript, which can be very dangerous and weaponized pretty easily. And with content security policies, one of the ways to actually combat cross-site scripting, in which server administrators and web developers can specify where domains can come from and which are valid resources that can actually execute scripts. So to combat cross-site scripting, you'd want to look into content security policy, as you can either specify it through a header tag or a meta tag. You'll get familiar with that in CSEC 380 as well. And one of the other big things is cross-origin resource sharing. That's one other the big concepts. It's defined by a bunch of headers like down below where you can basically set access control. And this is basically just headers that define origins for access to your data. And basically by configuring these, you can basically control who can access what on your website. You can, for example, restrict JavaScript requests, web fonts, and some other fun stuff. And then one of the other big vulnerabilities is cross-site request forgery, in which you can basically cause a victim to make a request from a site and in which the state of site B is changed. That's a little confusing, but there's a very good picture here that simplifies it. So basically, you can see number one, the victim would sign into their network. Number two, the victim visits your website, your fake attacker.com website that you set up, and your page contains CSRF code. So you can see like down below, it's putting a form for a post request, which is, it's showing how the input name is the attacker and the input amount value would be $1,000 going to your bank account as they're running that code once they visit your website, and the browser sends the request to the bank. So the money would go from the victim after they visit your website to your account. And to stop CSRF, you'd want to make sure to check headers, check the origin, and you can have tokens, for example, to verify. You can have like JSON web tokens. People usually generate tokens in a bunch of different ways depending on the language you're using. And you can also, there's also something called cookies, which is basically store of value, and you want to verify those as well. And now for like the biggest thing that web applications struggle with is SQL injection, or just injections in general, in which there's command injection, SQL injection, where you can basically dump the database, access data you're not supposed to be allowed to see. And there's also server-side request forgery, which we'll get into in a little bit. But with SQLi, you've probably seen the big one, like or 1 equals 1, semicolon, and #, which would basically just dump the database and all the tables within it. So this is basically where a program is trying to access the database and allows you to basically ask the database another question in the form of a SQL query. So there's a lot of famous examples, and it's one of the most dangerous ones, as you can do a lot of damage with it. One of the famous tools is SQL Map, of course, if you've ever used that before to play around with SQL injection. And command injection is just as worse, or even more worse, is where you can basically inject arbitrary commands to be run on the back end. So for example, you can see the backend code shell exec, which is a PHP function that will execute the command. You can basically, it's doing a get request for the page number, that HTML, so you can, as the exploit, you can just or put a semicolon at the end and execute any command you want, which would be very dangerous. You can get a reverse shell and get on the box and do some pretty bad things on there. But it can either execute backend languages or shell commands, so you'd want to identify what exactly type of server it is before you start exploiting it. And then for server-side request forgery, sorry it's a little scuffed, but there's a really good blog post that you'll see like when it's posted to the workplace. So just go over that blog post, as it just highlights like how someone discovered a vulnerability for server-side request forgery and managed to get $12,500, as the bug bounties for website vulnerabilities are pretty high, as they're very big usually. And one of the other big ones on the OWASP list is XML External Entity attacks, in which that means a website has a weak XML parser, so you're able to leverage it to your advantage. So you can see like down below the disclosure of Etsy password, for example. You can do system file / Etsy password, and that will basically request it from the XML parser because it's not properly set up. So it's disclosing the file that you asked for. And with just some random tidbits, like when you're doing like web reconnaissance, you want to make sure you check out like the basics. You want to make sure you check if there's a robots.txt, for example. You want to identify the server versions. You can do that through like Nikto. Nmap has some pretty good scripts. Usually one of the big tools that you'll be using is Burp Suite and Chrome DevTools or Firefox DevTools. But Burp Suite's basically just a proxy that will allow you to like intercept requests, change requests. It can even do active scans. It's one of the big things that you want to add to your arsenal if you're not familiar with it. And with going into a little more about the developer console, because Chrome has a pretty good one. You can even inspect elements, you can inspect the page, you can modify it, you can execute JavaScript and run it. You can even see errors thrown on by websites. If you ever like open up the developer console on just a random website, you might see some red there, which is errors on their end. And you can also view the TLS certificate. So if it's using HTTPS, which it should be, you can see their certificate, see where it's from, see where it came from. And just these are some resources. I'd say one of the biggest ones would be, the last one would be Portswigger, which is the company who made Burp Suite, as they actually released about 2 months ago, or maybe 4 months ago, they released something called their Web Academy, where it's basically just a free resource that anyone can sign up for. You don't have to be a student or anyone. And with that, they will essentially teach you the basics of like SQL injection, give you real hands-on exercise practice with it. There's also damn vulnerable web application as well, which you can set up through like Docker. There's Juice Shop, which will basically just set up like misconfigured web applications that you can exploit. And just be careful if you try and exploit websites you don't have permission to do, as that's kind of illegal. And that's all I got. Does anyone have any questions?
How do you break web?
How do you break web? You open up Burp Suite, start doing SQL map, and just pray.